PC Electronics. So today's video is 15 MCQ questions from network analysis. We all know that network analysis is a very important subject, especially in terms of competitive examination and its preparations. Okay, so today in this video I've tried to include 15 MCQ questions from network analysis covering almost all topics. And other than that, we are doing also numerical videos topic wise. So if you want to watch the numerical videos especially, you can see them in the playlist of network analysis. Okay, and also if you found this video useful, please don't forget to like, share and subscribe. So let's see what are the questions. So the first question is question number 1. So it is a basic question. The question is, an electric current of 10 ampere is same as dash. Okay, option A 10 joule per coulomb, B 10 volt per coulomb, C 10 coulomb per second, D 10 watt per second. So you can write current I is equal to charge per unit time or Q by T. So the unit amperes, the unit of current is ampere, right? So you can write amperes as coulomb per second also, since it is the rate of flow of charge. Okay, so you can write 10 ampere as 10 coulomb per second. Okay, so that is the unit conversion in terms of charge and time. Okay, so the correct answer here is option C, which is 10 coulomb per second. Okay, moving on to the second question. The second question is again from the basic things of network analysis. So the question number 2, Ohm's law is not applicable to dash. A, DC circuits, B, high currents, C, small resistors, D, semiconductors. Okay, so the correct answer here is semiconductors. In terms of semiconductors, we actually apply an entirely different theory. It is not Ohm's law. You cannot apply Ohm's law because semiconductors are sensitive to temperature. Their current or charge carriers will get generated due to temperature also. And here we have to have a very clarity about Ohm's law definition. It is defining that at constant temperature, the voltage is directly proportional to the product of, or V is equal to IR. It is, the Ohm's law is V equal to IR, right? So it is only defined at room temperature or at constant temperature. But in the case of semiconductors, they are temperature dependent materials, and hence the temperature has a major role in it. So you cannot apply Ohm's law in semiconductors, and also in case of insulators. Okay, so if the option is having insulator also, you have to pick it. Okay, so the correct answer here is option D, which is semiconductors. I hope the concept is clear to you. Moving on to the third question. Third question, you'll be seeing the questions. So the resistivity of a wire depends on dash. A, length of wire, B, cross section area, C, material, D, all of the above. So the resistivity is the property of a material. It is not depending on the length of wire or the cross section or anything. Don't get confused. If the question is regarding resistance, R is equal to rho L by A. So the resistance has a effect on the length of the material and the area of the material, but the question is regarding resistivity, and the resistivity is depending on the substance, material substance, or the nature of the material. Okay, so correct answer here is option C. Resistivity depends on the material type. Okay, so moving on to the fourth question. The circuit in which, fourth question, the circuit in which current has a complete path to flow is called dash circuit. The question is regarding the nature of the circuit. That is, if the circuit is allowing an entire path to flow for the current, then the circuit is called a dash circuit. A, short. No, it's not a short circuit. B, open. C, closed. D, open loop. Now, when the option is open means there is no current flow. So the option is not correct. And the correct answer here is option C, closed. Okay. So the question, I'll read it once again. The circuit in which current has a complete path to flow, it is called a closed circuit. Okay. Correct answer is option C, closed circuit. Fifth question. Fifth question is a small numerical type of question. I'll read out the question. You can see it on board. The voltage across R1 resistor in the circuit below is dash. Okay, so you can see that there are two resistors and both the resistors are of equal value, which is equal to 40 ohms. And there is a voltage of 10 volt. Now this voltage has to, the total voltage is 10 volt. So the voltage is, as they are in the series connection, the voltage has to divide between the two resistors, right? So since the voltage has to divide, we have to apply voltage division rule. Now if you see the value of the resistors, they are entirely the same. Since the resistors are of identical value, we have to just divide the voltage by 2. 10 by 2, which is equal to 5 volt. Okay, this is nothing but voltage division. Only thing is that since the resistors are of equal value, the voltage will also get divided equally. Okay, so here 10 by 2, which is 5 volt, is the voltage across R1. And if the question is the voltage across R2, it is also 5 volt. Okay, correct answer is option B. Now, moving on to the sixth question. How many type of dependent or controlled sources are there? So the question is here regarding the type of sources. So you can classify the sources as a broad classification: voltage and current source, right? The sources can be voltage source and current source. Now, if these sources are dependent sources, then you can again classify this as voltage controlled voltage source and also current controlled voltage source. So these are the voltage sources which are dependent on voltage and also current. Okay, so I'll tell it once again. VCVS means voltage controlled voltage source. So these are voltage sources. Okay, voltage controlled voltage source and current controlled voltage sources. So these are the two categories of controlled voltage sources. Now if it is for current source, again you can have the same classification: voltage control current source and current control current source. So I'll tell it once again for you. So these are the two classifications of controlled voltage sources. One is voltage controlled voltage source and second one is current controlled voltage source. Now if it is for the current sources, then there are two controlled types or dependent types, that is voltage controlled current source and current controlled current source. I hope it is clear. Now totally how many are there? 4, right? So how many type of dependent or controlled sources are there? There are 4 types, which is option D. 4 is your correct answer. Okay. Now moving on to the 7th question. The 7th question is actually a numerical question. It is from the simple resistance connection numerical. Okay. Now I'll read out the question for you. You can see the question on board. Question number 7. If the resistances 1 ohm, 2 ohm, 3 ohm, 4 ohm are parallel, then the equivalent resistance is dash. You just have to apply the formula and find the result. Okay, so the equation for finding the equivalent resistance is 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Since there are 4 resistors, you just have to put the values as 1, 2, 3 and 4. Now 1, 2, 3 and 4. I've substituted the values, and if you find the value of RT, you'll be getting is 0.48 ohms. Okay, so this is just basics of resistor connections, and if they are in series, you just have to add the values. Okay, now correct answer for this question is option B, which is 0.48 ohms. Moving on to this 8th question. Eighth question is, in a circuit with more number of loops, which law can be best suited for analysis? A. KCL, B. Ohm's law, C. KVL, D. None of the mentioned. Okay, so there are two type of Kirchhoff laws mainly, Kirchhoff voltage law and Kirchhoff current law. Kirchhoff voltage law or KVL is also called loop law. Sometimes we call it as loop law and also mesh law or mesh analysis. Okay, so these laws are based on the mesh nature or the loop nature of the circuit, which we use for solving and finding the properties, which can be voltage or current. Okay, so here we are considering or we are interested in the loops. Okay, so if it is a loop we are interested in, we are going for what? We are going for Kirchhoff voltage law or KVL. Okay, so the question I'll read it once again. In a circuit with more number of loops, which law is best suited? C, KVL is the answer. Okay, so that is the answer for your 8th question. Moving on to the 9th question. Kirchhoff current law is applied at dash. A, loop, B, node, C, both loop and node, D, none of the mentioned. So again, the question is related to the previous question. That is talking about the Kirchhoff current law or KCL. So this current law is applied at the nodes or the nodes of the network. So in this nodes, we'll be applying in various nodes, we apply current law, Kirchhoff current law. So the correct answer is B, nodes. Okay. Now, moving on to the 10th question is again related to KCL itself. So that's why I have not given the detailed explanation of KCL in the previous question. The next question is actually regarding to the KCL itself. Kirchhoff current law can be mathematically stated as dash. So, I'm not going to read out all options. I'll only explain the correct option. Okay. So, the correct option is sigma k equal to 0 to n, I equal to 0. Okay. Now, what this states is that if you consider a node, so in the previous question we have seen that we are applying KCL, which is Kirchhoff current law, to nodes, right? And this KCL or Kirchhoff current law states that the algebraic sum of currents at a node is equal to 0. That is a sum of currents coming to the node and leaving the node. If you take the algebraic sum of it, it will be equal to 0. And that can be mathematically represented like this. K equal to 0 to n. Consider that there are n number of currents coming to a node, then its algebraic sum is equal to 0. There is no I square in between, in front of it or I in front of it. Just the sum of currents is equal to 0. That is KCL. K equal to 0 to n. Sigma k equal to 0 to n, I equal to 0 means sum of currents. Algebraic sum of currents is equal to 0. Correct answer is option A. 11th question is, a graph is said to be directed graph if dash of the graph has direction. So the graph and tree structure is very important topic in network analysis. Okay, so a network you can represent in the graph form with nodes and branches. Okay, now a graph is said to be directed graph if dash of the graph has direction. A, one branch, B, two branch, C, three branch, D, every branch. The correct answer is if every branch in a graph is directed, we say it as a directed graph. Otherwise, if at least one branch is not directed, means we cannot say that the graph is entirely a directed graph. Okay, so correct answer is every branch has to be directed, which is option D. The 12th question, you can see the question on board. The question is from reciprocity theorem. So I hope that you know what is reciprocity theorem. If not, we'll be very soon doing a video on the numericals of reciprocity theorem, in which you'll be studying what is actually reciprocity theorem. Okay, now here the question is, in reciprocity theorem, which of the following ratios is considered? A, voltage to current, B, current to current, C, voltage to voltage, D, no ratio is considered. So the reciprocity theorem is like, first you place a EMF source or EMF in one branch and you see the or observe the current in other branch, then you place the EMF in this branch and you observe the current in the previous branch. So this relation between voltage and current is actually called reciprocity theorem, and it is taking the ratio of voltage and current, which is option A. Okay. Next question is question number 13. Okay. Let me remove this. Question number 13. The dual pair of current is dash. A voltage, B current source, C capacitance, D conductance. Okay, so you can have a dual pair in network also. We all know that you can represent voltage in form of current and current in form of voltage. So the dual pair of current is voltage. Just like that, there are other dual pairs also. Resistance, dual pair is conductance. Okay, then I hope you can see it, or else I'll write it below. Resistance dual pair is conductance. Also for capacitance, its dual pair is inductor or inductance. So these type of dual pairs are there. Now the question here is the dual pair for current. It is A, voltage. Okay, so the correct answer here is option A, which is voltage. Question number 14 is from star to delta. No, it is from delta to star conversion. It is a numerical question. Okay, first of all, you should be able to identify that the question is a conversion. Question is find the equivalent resistance at node A. You can see that there is a node A. There is an B, C and D. You have to find what is the equivalent resistance at node A shown in the circuit below. I'll draw the circuit for you. So there is a A here. There is a resistance here. Here also. Here. And there is a B here. And here there is C and D. Now these values are 12, 11 and 13. Okay. Now what is the resistance at node A? Now the resistance at node A will be the this node, right? Now if you form a star connection inside this delta, you can think of this outer connection as a delta, right? And if you form a star inside that delta, you can have a delta to star conversion. Okay, so the conversion we are doing here is delta to star conversion or Y conversion. Y can also be called as star. Okay, so this is star or Y. Delta to Y conversion. And what is the equation? A video is very soon coming on these conversions also. Please do watch it. Okay, so here we are going to have a Y network. And what is the resistance here? It is the product of the equation I'll write. Okay, write it below. RA is equal to 11 into 12 by the sum of these three outer resistors, which is equal to 11 plus 12 plus 13. Okay, so the concept is whichever node's resistance you have to find, take the resistances, product of resistances connected to the node. So here it is 11 and 12. Okay, so take the product of the 11 and 12 and form a numerator. The denominator will be the sum of three resistors in your delta, which is 11, 12 and 13. Now you may not see this outer connection as a delta, but just now this connection is exactly the same as if you connect this to this and this to this point. Now it will be a delta, right? Okay, so first identify that the outer connection is a delta 1. You have to convert that delta to star or Y. Okay, and the result obtaining is RA equal to 4 ohms. Okay, correct answer here is option D. Okay, so this question was a delta to star conversion, and the answer you are getting is 4 ohms is the equivalent resistance at node A. Now the last question is question number 15. Okay, you can see the question on board. 15th question. Which of the following is not an example of linear element? Very simple question, very simple question. A. Resistor, B. Thermistor, C. Inductor, D. Capacitor. The correct answer is thermistor. Other elements are very basic elements. They are having a linear relationship, okay? Or they are linear elements of network analysis or network. But thermistor is not a linear element. So the answer is thermistor. Correct answer is option B, thermistor. Okay, so these are the questions which I've included in this video. If you want me to continue this series, if you want me to do one more video on MCQ of network analysis covering entire topics, please do mention in the comment section. We'll be doing more videos on it, okay? And this video is very useful if you're preparing for AFCAT examination or ISRO technical assistant examination or any other competitive examination for that matter. So please do share it with all your friends who's preparing for any sort of competitive examinations, okay? So please do share it, and if you found it, please do give it a thumbs up. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.